All right, let's do some more practice. We're just going to do like a mix of different types of problems. So for number 3, it says the function represents the profit in thousands a company makes for selling X objects. So that means the objects are going to be our X, so the other one, Y, must be our profit. And we want to know how many objects do they have to sell to maximize profit. So what I'm going to do is just type in my function. So negative 5x squared plus 30x plus 144. And then we're going to look at this graph. And it says that we want to maximize the profit. So we're going to look for our maximum. So the top of that graph happens at 3,189. And it says we want the maximum profit. And so our profit is going to be our Y value because it told us that X was our objects. So profit is going to be 189. But one more thing is in this problem it says the profit in thousands. So that means that whatever number we have, it's going to be in thousands. So we got to multiply that by 1,000. Number 4, suppose that the equation represents the value of a car from 1964 to 2002, where x equals 0 represents 1964. During what year will the car be worth the least? So again, I'm just going to type that equation in, and I'm just going to use x's and y's for simplicity. So we got minus 458.3x plus 3,500. All right, so I've typed that in, and it says, when will this car be worth the least? So the least means that we are looking for that minimum value. Okay, so that minimum happens at 1975, or not 1975, 975. So our x value says x represents the year, so that's after 11 years, it's at its lowest value. But the key here is it says in what year, okay? And we didn't start at year 0, we started at, our 0 year was 1964. So that means 11 years after 1964, the car was at its lowest value. So I'm going to have to add 1964 and 11 to figure out what year that was. So that would be 1975. All right, for number 5, the expression can be used to estimate the height of a toy rocket. How many seconds does it take the rocket to hit the ground? So I think there's a typo on this one. This should be a negative in order for that to accurately show the path of a rocket. So that's going to be negative 5x squared plus 25x plus 70. And we're going to find our graph wherever it is. There it is. And we want to know when it hits the ground. So there's our maximum. Okay, that's what we've been looking at before. But we want to know when it's hitting the ground. So the ground is when the height is at 0. So that's when the y is at 0. So that means we're at our x-intercepts. And it's asking for seconds. So our options are either -2 or 7. But we can't have negative seconds. So it's going to be after 7 seconds. So it's right over there. Number 6, the function models the height above the ground of a jumping frog, where x is the horizontal distance. What is the horizontal distance that the frog traveled during its jump? Okay, so y equals 2x squared plus 10x is going to be our function. Let's see here. I think that one should be negative as well, just to show the jump of a frog. So the key here is we've got to find our starting distance and our final distance. So it says x is our horizontal distance. So it'd be really easy to look at this and say that, well, I guess we're just going to want to look at our from the ground to the ground, right? So since it's horizontal distance, if it was time, we probably would want to use our 0 value from our starting point, so like our maximum. But since that's our horizontal distance, that means that we can use both of those x-intercepts because distance can be negative. He can go backwards. So we just want to find the distance from when he was on the ground the first time to when he was on the ground the second time. So I'm going to do 2.236 minus that negative 2.236, and that means our frog jumped 4.472 centimeters. Number 7, for which interval is the function increasing in the first quadrant? So let's graph that. If you haven't noticed, the first step is usually to graph it so that we can visualize it. All right. So if you remember from 8th grade, our quadrants go clockwise. So this would be quadrant 1, 2, 3, and 4. So we want to see where the slope is positive, where it's going up. So looking at, I'm going to cut off, so like we're just looking at that top right quadrant. So let's zoom out a little bit. Did I do that right? That's what I have typed it in as a linear function squared. There we go. So if you're having trouble finding your answer, make sure that you typed it in right. Okay, so I'm going to kind of cut off, so we're just looking at the top quadrant. But we want to see where it's increasing. So that would be when it has a positive slope where it's going up. So we can see that from 0 to our maximum at 4, that graph is increasing. Whereas once it hits its maximum, it starts to decrease. So that means between 0 and 4. Now technically, it is increasing from negative infinity to 4, because you can see that on this left side it goes all the way down, but it only asked us for the first quadrant, so it's asking for that top right quadrant, so that would be B. Alright, number 8, some fireworks are fired into the air from a platform that is 4 feet above the ground. The height of the firework after X seconds is modeled by the function. For which interval of the time is the firework coming back down to the ground? Okay, so let's type that in. Negative 16x squared plus 64x plus 4. So we can kind of see our firework, right? It starts 4 feet off the ground, right there at 4, and it's going up, 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 until it reaches its maximum height at 68 feet. And then we want to know what interval of time it starts coming back to the ground. So once it reaches its peak height at 2 seconds, so that means we're starting at 2 seconds, that's when we start to fall, and then all the way down until it hits the ground. Right, there's the ground at 4 seconds. So it's going to be from 2 to 4 seconds. A couple more, guys. So 9, the equation models the daily profit of a company if it sells X items. So X is going to be the number of items, Y will be the profit. One day the company's profit was 1,750. How many items did the company sell that day? Okay, so we're going to type that in. So Y equals X squared minus 45X. Okay, and we want to find where the profit is 1,750. And since we know that X is our items, that means our profit is going to be our Y. So if we check this out, there's a couple ways to do this. We can scroll around until we find where Y equals 1750. But that might take a little while. So another way to do that would be just to type in Y equals 1750 and see where those lines cross. And obviously that's going to be a positive value because we don't have negative items. So that would be 70 because we're looking for our our x value. We're looking for what is our x value and y is 1750. Another way to do that would be to make a table, and you could go through that way until you see the profit you want. It would just take a while because we're going to have to go all the way up to 70. All right, last one. An object is launched at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, s, so that means s, or this one over here, which is normally our y. So height is going to be our y. At time t seconds, so t, or what is normally x, will be our time. How long does it take the object to fall to 24 meters? So how long does it take, how many seconds, how much time does it take to get where a y equals 24? So we'll type that in again. Negative 4.9x squared. And I missed my 0.9. Plus 19.6 x plus 58.8. Alright, so there it goes, and we are looking for that y value of 24. So I'm going to type in y equals 24 and see the positive value where those lines cross. So that is at 5.332 seconds.